Now, I wouldn't say the question we're about to do is a difficult question. However, it does test a concept that a lot of people aren't very comfortable with. And that is the concept of a type 1 error in a discrete distribution. So your Poisson distribution or your binomial distribution. Now, when you talk about type 1 errors, the basic idea, as you all know, is when you reject your null hypothesis, even though your null hypothesis was true. And the probability of doing that in a continuous distribution is very easy to calculate. Well, that's not a nice curve. Um, if you have if you talk about your normal distribution and you're doing an upper tail test, and this is basically your significance level of, let's say, 5%. Your significance level in a normal distribution corresponds to the probability of your critical region or your rejection region, whatever you like to call it. And since you'll only reject H naught, that is your null hypothesis, when it falls into the rejection region, your significance level effectively becomes your probability of rejecting H naught, which then effectively becomes your probability of your type 1 error. So it's very, very simple in your continuous case. In your discrete cases, um, type 1 error, the probability of a type 1 error is the same as the probability of your critical region or your rejection region, whatever you like to call it. But you can't simply quote your significance level here, because in discrete cases, your significance level doesn't always correspond with your critical region. And if we see a question on this, so we're going to be doing part 2. Now we already would have found the critical region. It was x is less than equals to 1 for the given test in part 1, and that's not the focus of this video. Finding critical regions in binomial distributions or Poisson distributions. Well, that is another concept that most people are fine with. You just simply manually find the probability that x is 0, x is less than equals to 1, so that's 0 plus 1, x is less than equals to 2, which is 0 plus the probability that x is 0, the probability that x is 1, that it is true, and you keep doing so until you overshoot your significance level if it is just a one-sided test. So wherever you overshoot, wherever your probability goes over 0.05, let's say, you will stop and you take the x value behind that. So in this case, when you calculated x is less than equals to 2, it overshot 0.05, and which is why we picked x is less than equals to 1 as our critical region. And the probability of the critical region, as we've already would have calculated in this question, is 0.0314. And again, the key thing here, it does not necessarily correspond with your significance level. In a continuous case, your significance level would have been the probability of the rejection region. It would have simply been 0.05. It's not so in this case. So explain the meaning of a type 1 error in this context and state the probability of a type 1 error. The question is, the test in the question is whether the mean has decreased. So because the type 1 error is where you're rejecting your null hypothesis even though it was true, so you would like state or deduce that mean has decreased, because if mean has decreased, you're rejecting your null hypothesis and adopting the alternative, which, even though the alternative isn't true, your null was true. So you state that mean has decreased even though it hasn't. And the important bit, the bit I was making the video on, is the probability of your type 1 error. This again is not difficult. It's just you need to get your concept clear on this. It's just the probability of your critical region. So it'll just be 0.0314, and that's it. The only issue people have is they start to quote your significance level and don't realize that the probability of the critical region varies from the significance level, can deviate from the significance level in a discrete situation. So they could very well give you a question just asking the probability of a type 1 error, and you have to calculate the probability of the critical region and all just in one part. So all of that could happen. But that's it for this video.